Good day, welcome back. We continue with inverse functions. Just a reminder, an inverse function is a reflection of the original function in the line y is equal to x. Meaning, whatever my x value is or my y value is of my original function, it will change to x values. Whatever my x values are will change to y values. We will look at exponential function in this instance. Right, when we are given the exponential function and we need to write the inverse of the function, first step I do is I write it in the form y is equal to 2 to the power of x. My next step, x and y must interchange. So, when x and y is interchanged, I need to make y the subject of the expression now. So my next step, y is an exponent. The only way I can get that exponent to the floor is to attach a log and to attach a log. Only in logs does this exponent jump to the floor. So I attach a log on both sides, because what I do on the left hand side I must do on the right hand side. And whatever I do on the right hand side, I must also do on the left hand side. So now my y jumps to the floor, and I have log of x is equal to y log of 2. Now I divide by log of 2, divide by log of 2, and I have y is equal to log of x over log of 2. This means log of x base 2. Now in my next step, I would like to draw the graph. So if I want to draw the original graph, I will say I have to choose values that I will plot in here that will give me values in order to plot the graph. So if I plot minus 1, 2 to the power of minus 1 is a half. 2 to the power of minus 2 will be a quarter. If I have 2 to the power of 0, that will give me 1. 2 to the power of 1 will give me 2. 2 to the power of 3. 2 to the power of 2 will give me 4. And 2 to the power of 3 will give me 8. Now I go to my graph paper and I plot these coordinates on the graph paper. When I have 2 to the power of minus 1, it's a half. 2 to the power of minus 2 is a quarter. And 2 to the power of minus 3 is an eighth. Now remember what we said, that every coordinate, if I go to the mirror, I move away from the mirror the same amount of places. I move to the mirror, away from the mirror. To the mirror, away from the mirror. Now, to the mirror here, and I go away from the mirror, I can go in this direction also to the mirror, and the same distance away from the mirror. Then I will get more or less a graph that I can draw. Remember, this graph won't touch this line. It will come increasingly closer to the line, but it won't touch. The same will be happening on this side. So here are the actual two graphs, the original graph and the log graph of the function. You will notice that the same distance 2 will also be the same distance from the mirror. If I pick my values in my graph, so I will use values that is multiples of the base 2. So 2 to the power of 1, which will give me a 1 in front, and 2 log 2 divided by log 2 will cancel out. If I use 4, that will be 2 to the power of 2. So the 2 jumps to the front. So I have log 2 divided by log 2 will give me 1. Multiply by 2, answer will be 2. 2 to the power of 3. 3 will be in front. Log 2 will cancel out log 2. And my answer will be 3. And log of 16 will be 2 to the power of 4. 4 jumps to the front. Log 2 cancels out log 2. I'm left with 4 times 1, which is equal to 4. So then I just plot the values and I connect the dots to get my graph. Thank you for watching this video. If you liked it, tell your friends. If you loved it, tell everyone. I will see you in the next one. Do not forget to like, subscribe and turn on notifications to be notified when new videos is uploaded. Please share if you found this useful. Thank you. Goodbye.